Hi guys. I think some of you are needing help with 5.3B practice, and I want to help you with that. And so I found a reading, which I'm going to read to you, and we'll do a play pause it on it. So it'll be your listening and your reading and your writing for the week, but it will also help you with kind of coming up with the right phrases and words to go into your poplet that you have to do. And once you finish that, then you can do your summative um, for 5.3. And so this is all just to help you. So here it is. Let me open it up. And we'll just have one reading for the week, so because it's kind of long. But you're looking at the 7 forms of energy, and that's what Mr. Rife would like for you to write about. You have to write how it's kinetic or potential, and then how is that energy transformation occurring. So don't worry about reading and highlighting, but we're just going to read through it quickly. Electricity. So we're looking at the pathway of how electricity gets to your home. And this starts at, for one of his, Mr. Rife in conceptual physics, one of those diagrams, this is about where the middle is, okay? And then I know you've seen these little pictures before, but how it gets into your home. So it's kind of starting at the end and then working its way back. So this is like you can use this information to create your poplet, and you can also use this information for your summative, okay? So electricity. So now we have the total transformation of coal generated electricity working backwards from the generator through the turbine into the steam, stopping at burning coal. We have 4 different energies that are used along the electricity generating process. So, chemical energy. In Ohio, electricity begins with burning coal. Burning coal releases chemical energy. Chemical energy is the energy given off during a chemical change. During chemical changes, atoms rearrange, creating new molecules and compounds. When they rearrange, they give off energy. Even just burning something as we do with coal is enough to cause the atoms to rearrange and release chemical energy. When a chemical change occurs, there are a variety of signs that help identify when the change is occurring. Indicators such as gas formation, light generation, heat creation, formation of a precipitate, permanent color change, and odor are all signs that a chemical change has occurred. When one of the signs is present during a change, chemical energy is released. The reason we use coal, oil, and natural gas is because when burned, the chemical energy released gives off lots of thermal energy and some other energy as well. Thermal energy. When coal is burned, a chemical change occurs. We know this because coal gives off lots of thermal energy. Heat. It also displays all the signs of a chemical change: gas, light, heat, precipitate, color, and odor. In order to capture the thermal energy in a more usable form, power plants heat water. Using the heat directly isn't as efficient as heating liquid water. Since thermal energy refers to the kinetic energy of the molecules, it's easier to increase the kinetic energy of a liquid molecule than it is a gas molecule. Think of it this way. There are a lot more liquid water molecules in a small bucket than there are water vapor molecules in a whole classroom, maybe even on the whole 6th grade floor. Since there are so many more in a small space, they can absorb more thermal energy. When we draw solids, liquids, and gases, the picture shows solids and liquids tightly compacted, but gas molecules spread out and are flying around. It's easier to heat things when they are tightly compacted. Imagine trying to shoot a molecule with an arrow. The arrow, in this case, is heat. The liquids and solids would be pretty easy, but the gas molecules will be flying around and much more difficult to hit. Thermal energy is kinetic energy. Mechanical energy. Once the water molecules start dancing, they turn into steam. The steam molecules now have lots of kinetic energy. Again, telling you what it is. Power plants want to use the kinetic energy to make things move. Power plants use steam to spin a turbine. Remember, the mechanical energy is energy of position, which is potential energy, and energy of motion, kinetic energy, so it's both. Since the turbine is spinning, it has motion, which means it has kinetic energy. When we talk about the forms of energy, we usually talk about the general form, in this case, mechanical energy, electrical energy. Although the spinning turbine is fun to watch, it's not a useful form of energy. You don't see too many people walking around with giant turbine powering their iPods. So, another transformation must occur to use this energy. The turbine is connected directly to a magnet. As the turbine spins, the magnet spins. The magnet is wrapped with copper wire. As the magnet spins inside the copper wire, electrons start to jump from atom to atom. When the electrons jump, they give off energy, which, as we have discussed, is electrical energy. So that's where that comes in. Sound energy. The title of this assignment is The 7 Forms of Energy, but we have only identified 4 in the coal-generated electricity transformation. There are others that enter the picture along the way. So again, it's giving you the answers. Let's take your TV. As the electrical energy powers a television, it produces 2 different types of energy. One type is sound energy. Sound energy is defined as the energy of vibrating molecules. Sound energy works by pushing and pulling molecules. Typically, speakers push and pull the air around us, which is why we can hear a TV or a radio. When the molecules are pushed and pulled, they collide, transferring sound energy. And if you are picking up on this, but that's kinetic energy because it's moving. In your TV, electrical energy vibrates a speaker. When speakers vibrate back and forth, they vibrate the air molecules. The stronger the speaker vibrates, the stronger the sound. If there are no air molecules, there can't be any sound, which is why a movie such as Star Wars has a big scientific mistake. When a spaceship blows up, it wouldn't make a sound in space. The movie would be kind of boring without all the special effects. So movie makers use some creative license and have sound in outer space. Light energy. The other energy that comes out of your TV is light energy, which is why it is fun to watch. Your television produces light energy by transforming electrical energy into light energy. Light energy comes from the vibrations of electrically charged particles. Those same electrons that we got jumping from atom to atom back at the power plant strike molecules inside your TV. Based on which molecule the electrons strike, they create red, green, and blue light, which combine to give all the other different types of colors we see. Nuclear energy. The final type of energy is one that we use clear back in the beginning of the electricity generation process. Instead of using coal to heat water or oil or natural gas, we can also use nuclear energy. Nuclear energy is defined as energy that comes from changes in the nucleus of an atom. We either break the nucleus apart to form different elements or press together one nucleus with another nucleus to form a new element. There are 2 ways that we can change the nucleus of an atom. One way is actually splitting the nucleus apart. This is called nuclear fission. This is the most common type of nuclear energy on Earth and one that gets lots of publicity. Nuclear reactors use fission to create their energy, as does the atom bomb that cause a lot of damage. Fission works by shooting a neutron like a bullet at other atoms. When the neutron collides with an atom, it strikes the nucleus, splitting it in half. Since the neutrons of the atom are splitting in half, there are now two neutrons looking to collide with more atoms. Once these 2 neutrons collide with other atoms, they split those atoms into 4 neutrons, which now are looking to collide with more atoms. This is called a chain reaction because the chain continues to grow by a factor of 2. 1 collision becomes 2, which becomes 4, and then 8, and then 16, and so on. Each time a nucleus splits in half, there is a lot of energy that is released. This energy is called nuclear energy. It is very hot as well as very dangerous. It gives off a special type of light called radiation. When controlled inside a nuclear reactor, it heats water, turning it into steam, which can be used to turn a turbine, just like the heat from coal is used to spin a turbine. The other way nuclear energy occurs is through the process of nuclear fusion. Fusion happens when the nuclei of 2 different atoms are pressed together, fused to form a new atom. This does not happen easily on Earth. It does happen close by Earth, though. The sun is constantly combining hydrogen atoms into helium atoms, which is why the sun is so hot. It takes millions of degrees to combine 2 atoms, which is why we struggle to make this type of energy on Earth. but it's not impossible. The technology to create nuclear fusion is becoming better understood. Scientists have been successful in making clear nuclear fusion happen. They believe that in the next 30 years, the first power plant using this type of energy will be available. The neat thing about nuclear fusion is that the fuel comes from water. Nuclear fusion uses hydrogen to press into other atoms. As it is pressed into other atoms, it releases the energy as heat with no nasty problems like those that occur with nuclear fission. So, that is how those energy transfers go. So, you can literally take this document and work backwards. So, nuclear energy, light energy, sound, electrical, mechanical, thermal, chemical, and then we have electricity. I hope this helps.